Hi, welcome to another episode of Jason's World of Insightful Things. Today, we're going to be replacing this old 60 amp screw-in fuse panel with a brand new General Electric 120-240 split phase main disconnect house residential breaker panel. What we're going to do is show you the basics, just to give you some indication that it is possible to do this by owner instead of having, a couple $1,000 bill. Going. All right, so we're outside. This is right outside. Here's the LB that goes down into the house. I don't recommend doing this, but this is what I'm going to do. And we are going to just cut this. And we're going to save this for later. This is our tag for the meter company, the electric company. We're going to take the base ring securing deal off. Looks like this. We'll put that somewhere. And voila, that's the back of the meter. So theoretically, we're not stealing anything because we're not using anything. I'm going to set the meter base down here and come on over. Let's take a look at these wires. So these wires right here are the hots that are coming in from the weather head above. And if you come back down here, middle ones are neutral. And here, and then these two are going down to the house. All right. So, with that said, and a face full of dust, let's go back inside. Go on.
See something. Yep, it's going.
All right. So now that we've gotten this all figured out, the outside is dead. What we want to do is just verify that it's dead, which is always a good idea. So I'm going to get some more light for one. Try to put it up there. And let's just verify, for the sake of doing it, that this circuit is dead. So now I'm going to go get my trusty multimeter. I don't know where my no contactor pen is, but we're going to use our multimeter today. And that's this gizmo right here. And it looks like we're good to go. So first thing I'm going to do is start taking all these fuses out. We'll save those. Never know when you need a fuse somewhere in a job. So these fuses would be equivalent, for those who are not that familiar with panels, these would be equivalent to the breakers that we're going to put in. The only difference is that these fuses basically will blow by virtue of heat. There's a fusible link inside. I don't know if you can see in there. Inside there's a piece of lead and some metal. And when the amperage gets too high and the load on this circuit, what it's designed to do is just the fusible link melts and the circuit opens. So in the electrical world, open is basically off, closed is basically on. So that's how we look into talking about that kind of stuff. So the first thing I'm going to do is start pulling out, looking at my wires. This is concerning to me. I got wires right here that don't really go anywhere. It's an open end. It can touch something and arc out or ground. That's never a good thing. I'm just going to start peeling this back. So I'll do one circuit with you just to show you what that might look like. Let's open this circuit right here. What I like to tell people when you're doing circuits and doing any lug work, one hand with insulated tools is the best practice. In case anything is live, you can at least have a chance to not get shocked and potentially electrocuted. So once I start seeing what's what, I know this yellow goes to this piece of EMT. Now I'm going to go look for the neutral of the same. And this neutral is barely even put on there. It's not even wrapped around the screw terminal. I don't know if we can see in there, but you got to see this. Look at this neutral, how they landed it. This is the one I'm after right here. It's not even around the screw. It's just basically wedged in between a bar. So that's exactly why we're doing what we're doing here. So basically, here's one of many circuits that I'm just going to try to get out of the way. And I will see you back here in about 10-15 minutes. Stop. Right.
All right. And relax.
You can kill it.
Pause it.
You can kill it. All right, let's come on in here, have a look. So this here is the neutral. It's a little short, but we're gonna make it work. All right, we're back. So since last time we took a check-in here, I actually got power, so we're live now. We got power from the outside. We put the meter back. Just a note, the meter goes back just like the way you took it out. The only difference that I was debating on videoing is showing to check the lug tightness outside. Terry, my videographer, and myself were both looking at it, and we found that we could probably get another turn to a turn and a half out of each lug, even on the hot coming from the utility pole. So that's not good. So we were able to tighten that up so we have nice tight connections and we don't get hot spots and damage our equipment inside the house. So we have the two hots here. It does not matter when you land the two hots into this master 100 amp disconnect. It does not matter which order you put it in. This isn't three-phase, it's split-phase, or what's called single split. And it doesn't matter which order. You're not going to phase reverse anything in your house. As long as neutral is neutral, ground is ground, and hot is on a breaker that's the right size, you're in good shape. So what we started to do is take everything that we had available, like this conduit here, so we could get light and we didn't have to rely on flashlights. We started making everything even with the breakers that we wanted to put back together. So for instance, this dryer box right here is 30 amp. We landed, came right in the side. I didn't have to redo any of the rat tail or flexible metal clad cable. It goes right in the side. We reused the nuts, the cable nuts for the landing in this panel. Just did the right knockouts. The next thing I'm going to do is take this grounding bar and I'm going to ground out at the bottom of this panel with this wire so we can bond this panel to earth. So right now, a lot of these conductors that I see in these old Romex style beginning conduits with the sheath, there's a lot of knob and tube still in the house, so it doesn't have a ground. So whoever had this house added grounds to pipes and all kinds of things so they could get the outlets to all pass inspection and have a ground. But today, in the modern day and age, as I was explaining to some folks, the panels of yesteryears without grounds or limited grounds, it doesn't accommodate the equipment that we use today. We have very precision equipment, highly precise equipment that needs harmonic filters, it needs that ground so it does, gets away with the noise, like computers, power packs, those types of things, televisions. So we really need to make sure that we have a good solid panel. So that's why I'm doing this project to begin with. A is to undo any of the evil that was done in the house. 2, so I could put the generator in here properly instead of the setup that I have today. And then 3, I could add more power to the garage. So we're on our way to success. I'll check back in with everybody here in about half an hour.